Welcome. Thanks for joining the webinar today. So the topic we are covering today is advanced planning and scheduling for multi-site, multi-plant operations. We're going to do a deep dive on how Infor Cloud Suite or Sightline APS handles planning and scheduling across multi-site, as Con said, multi-plant and multi-warehouse environments. So as Con mentioned, we've got a Q&A period at the end of this the presentation here. So you can ask your questions during the presentation and I will get to them at the end. All right, so a brief agenda. We're going to cover 5 different areas. So we'll start with foundations of what APS is built to do. We'll continue on with discussing the 3-pass planning logic behind reliable promise dates. Then we'll get into multi-location, the site versus shop floor discussion, multi-warehouse coordination, capacity planning, the engineering foundation that makes it all work. And then we'll have a question section at the end, as we talked about. So starting off in foundations. Before we get into multi-plant or multi-site complexity, it's worth being precise about what a planning system is actually for, what APS is actually for. So the core objective of any material planning system at the end of the day is to deliver what you promised on the date that you promised. This goes for APS, it goes for MRP, it goes for MPS, master production schedules, manual planning, reorder points. At the end of the day, we all want to be able to ship what the customer wants when they need it in the quantity that they require. To meet that, you need to know what materials that you're going to need, whether it's raw materials or manufactured components, and how far in advance you're going to need it. So APS, Advanced Planning and Scheduling, exists to answer those 2 questions reliably. That's the whole game. That's the whole point of APS. And the complexity gets more difficult as you add plants or sites. So APS does 3 things. The first thing is it helps you make a good promise when you take the order. That's that available promise calculation, available to promise calculation that you've probably heard, capable to promise in some of your environments. That's where you take the order, you determine a single planning run to define when you are able to ship based on the current snapshot of your planning and scheduling environment. The second thing that APS does is plan, supply, and adjust in time fashion to be able to keep that promise. That means that APS, as we'll talk about, doesn't plan to maintain high utilization at machines or work centers. It doesn't plan to carry excess inventory levels. It plans to have supply be available for customer order shipments just in time when they're needed, with caveats such as building in buffers. The third thing that APS does is alert you when a promise is at risk via exception messages. So some important framing about APS. Any of you that have sat in on my webinar a couple of years back or watched it on our YouTube channel, you would have heard me mention that APS is not fast MRP. So APS is not the next step for companies that are using MRP, not necessarily anyways. APS is different logic. So as I mentioned, it's not designed to maximize utilization on the shop floor. It is designed to hit promise dates. So if you're looking for a solution to level load production and maximize utilization, you may want to look at something like master production schedules where you decouple your demand and your supply plans. Second topic from the agenda is the logic of reliable promises. So this is that core mechanism, how APS actually arrives at a date that it can stand behind. So this is what we call the 3-pass planning method. The 3-pass planning method involves a first pass, which is a backwards pull plan from the due date. So the question that's asked during this planning stage is, do we have stock? Can we get deliveries? Can we make or buy the inventory in time? If all of those questions are answered as true, then the pass stops there. The planning run stops there, and it functions very similar to MRP in that scenario. So in that scenario, when you're calculating a promise date, that promise date would be the due date. You wouldn't get an exception message. You wouldn't get a warning from the system that the projected date is later than the due date. Now, if any of those questions fail, do you have inventory on hand? Can you get the supply on hand in time? If any of those questions fails, then the second pass gets triggered. So in that scenario, when the first pass occurs, if any of those questions are no, the start date in order to meet that date in the first pass would land in the past. APS will not allow a start date in the past, unlike MRP. If a start date lands in the past, that will trigger the second pass of the planning and scheduling method, pass 2. That's a forward plan, a push plan from today's date to provide a realistic worst case projected date. So that means that it will take a start date of today. It will count forward, not necessarily minimizing slack or anything like that, and it will calculate a worst case scenario of a finish date and determine what that projected date would look like. Now, you never actually see that projected date with a forward pass, because anytime the second pass triggers, the third pass will trigger immediately after. The third pass is another backwards plan, a pull plan from the worst case scenario projected date that was calculated in the second pass. It will count backwards and determine whether any slack or reprioritization of material soft allocation can occur, and improve that date if possible. The forward and backward plan algorithms differ, which is why the third pass can often improve on that projected date. So the date that you see at the end of the day, the projected date on your get ATP calculation or on your projected date on an order or a job, that will be a result of that third pass occurring if the first pass was not able to be successful. So a graphic here just to hopefully provide a bit more clarity on that. So in the first pass, as you can see here, we anchor work to the due date and count backwards. So in this scenario, the required release lands in the past, as you can see, therefore it is not a feasible plan. That triggers the second pass. The second pass, as I mentioned, will start on today's date. It will push forward and it will land on a due date at a worst case projected date. When the second pass triggers, the third pass will trigger immediately after. The third pass will take that worst case scenario projected date, pull the work tight, squeezing out any slack, reprioritizing soft allocation of materials if needed, and likely improve on that projected date. The final date is what you will see in the system and what you will communicate with the customer. So making the promise at order entry. The logic that we discussed in the previous 2 slides will surface at the order entry level using the get ATP or get CTP calculations. For any of you that have seen one versus the other, the difference between get ATP and get CTP is whether or not you have finite APS enabled. So if you are using finite capacity planning, you will see get CTP as your capable to promise calculation. If you are using infinite APS without capacity planning, you will see get ATP for an available to promise calculation. So this logic will test the demand against the live plan. So the planning and scheduling environment that has been generated by the most recent APS run, it will do a single pass to test that demand against the plan and return a projected availability date. The label that you get depends on your mode. So as I mentioned, infinite's ATP, finite is CTP. You can run the calculation to get ATP or CTP on a line level. So you can run it for every order line, or you can run it at the header level to get a calculation across all lines. Whether or not you allow partial shipments will control whether or not the available to promise date that's calculated is the same for all lines, or if each line is calculated individually. For those of you that have played with the settings, there's also a function in your planning parameters to set the parameter to calculate all order lines automatically. Essentially, as you create an order line, an ATP calculation or CTP calculation will run when you save the record and prompt you to confirm the date. So everything we've discussed so far applies to a single facility. Multi-facility, whether it's multi-plant or multi-shop floor, will use the same logic, but then there's some additional planning criteria that will be considered as well. So what we're going to discuss here is what happens when you manufacture across multiple physical locations. So could be multi-site, could be multi-shop floor. We'll discuss the differences, the similarities, when it might make sense to use one versus the other. So many companies have multiple physical locations that can manufacture product. In the past, our recommendation and Infor's recommendation was always to use multi-site, meaning that each location that performs any manufacturing gets set up as its own site and site line. However, there is an overhead associated with that. So you need separate sets of master data, separate financials, separate logins for every site. There's quite a bit of administrative overhead to run two sites concurrently, and for a lot of companies, they don't actually have separate legal entities. So they may be running a multi-site environment because that's the functionality that was available to them to be able to manufacture and plan independently in two different facilities, but they don't actually have a requirement from a financial perspective for, consolidated financial reporting or, different currencies or whatever else comes in a multi-site environment. So Infor is in the process of coming out with a feature that is called multi-shop floor. We're going to do a quick comparison between the historical multi-site functionality and the new multi-shop floor functionality. So multi-site, as I mentioned, separate legal entities that roll up to a parent company, a corporate company. They each generate their own financial statements, which you can consolidate or not. Master data is typically maintained independently. There may be replication rules set up between sites to duplicate the data, but it exists in separate database tables. Well, same database table, but separate site references. MRP and APS will recognize the structure and plan each site independently. You are able to run global planning and have the system be aware of transfer order requirements between sites. So some of you will have heard me talk about that before. Multi-site makes sense to use when facilities genuinely need individual financial reporting. So if they're different companies or they require, different financial statements, different currencies, anything like that, that's where it makes sense to use multi-site. Multi-shop floor is, as I mentioned, it's a new feature. It is currently in kind of a partial release state. So MRP, there are beta keys available if you're on the current version of Sightline or in the cloud. There are beta keys available to turn on multi-shop floor for MRP. And for APS, it is coming later this year, which we'll talk about. So multi-shop floor has been something that's been requested by a lot of companies for quite some time because, as I'm sure this applies to some of you here in the call, there are many companies out there that have more than one manufacturing facility but one legal entity. So that's what multi-shop floor is meant to achieve. Multiple plants under one legal entity, no impact on financials. However, you will still have independent planning per facility. You won't have a duplication of master data because it's built on the existing warehouse structure that is inside Sightline within a single site. Multi-shop floor for APS is scheduled for delivery 7 in Infor's roadmap for beta testing in late 2026. I believe it's the October release. If anybody's curious about when that will be available, if they would like to get a beta key and start testing that for their organization, reach out to me or Con and we can get you more detail on that and help provide a roadmap of what that's going to look like later this year. If you are on MRP and you're interested in multi-shop floor, you can get a beta key for that right now, and it should be fully released, I believe, later this year as well. So mechanically, here's where we'll discuss the division of responsibility. At the site level, you will maintain things that are tied to the legal entities, such as your open ARs, your AR aging, your AP aging, your general ledger, master data such as customers, vendors, and items, your chart of accounts, your base currency, your accounting periods, and the tax ID of your legal entity. At the shop floor or plant level, you will maintain operational detail, such as operational sub-warehouses, work centers, resources, resource groups. Using multi-shop floor, you can set up independent bills of materials and routings by warehouse. You can perform planning independently by manufacturing plant in a single site environment, as well as maintain separate costs by warehouse. So that's where multi-shop floor avoids that master data duplication. That administrative overhead, that heavy stuff, it stays at the site level, and the warehouse level is used really just for the manufacturing and costing components. So this is an example of what that looks like structurally. So we've got a corporate legal entity. So this is an environment where we've got multi-site, but we also have multi-plant within one of the sites. So we've got our corporate legal entity. We've got 6 sites within this environment. So 6 legal entities. We've got manufacturing and distribution that's occurring in a few different sites potentially, but 4 is the one that we're looking at as an example here. So each site could be individually planned. Let's say sites 4, 5, 6, as an example, all have manufacturing plants. Site 4 in this scenario has 2 manufacturing plants. We've got the shop floor in Toledo and we've got the shop floor in Columbus. So 2 separate warehouses, another 2 warehouses strictly for inventory distribution in Cincinnati and Cleveland. So in this environment, we've got both multi-site and multi-shop floor configured. So we've got the multi-site at the site level where we've got independent legal entities that may perform their own manufacturing. And then we've got a site that's got its own multi-plant setup where we've got individual manufacturing plants in different locations in the state of Ohio that are planned independently and manufacturing is set up independently between the 2 facilities. And that would all fall under that one legal entity for Site 4. So in terms of operations, this new functionality gives you flexibility. You can run MRP or eventually APS planning for a single plant or all shop floors of a site at once. The same product can be manufactured differently in different facilities. So if you've got more than one plant where you've got a different manufacturing process, we can have separate bills of materials and routings, as I mentioned, set up at each facility, each manufacturing plant in the system. So you can build out your current BOMs by shop floor to capture any subtle differences in the manufacturing process. There is a sequencing piece to consider as well. So you can set a planning sequence between your manufacturing plants and the number of passes that should occur. For instance, if you set your multi-shop floor up with 2 passes, after the first planning pass runs through the plants in sequence, there will be a second pass that runs through to consider any transferred demand that was generated during pass 1. So in that case, if there's any inventory movements between plants, that cross-plant demand will be fully resolved. So plans don't plan in isolation for multi-plant or multi-shop floor. So the next point that we're going to discuss here is how APS will pull together a multi-warehouse supply chain across your entire organization. So APS will integrate supply from across your multi-warehouse environments. That will include on-hand inventory, purchase orders and job orders, transfer orders, and project outputs that will all feed your APS plan. When it plans a supply for a transferred item, it will create planned transfer order demand at the time that the supplying plant dictates so that the chain between warehouses stays connected. This extends to providing promise dates. So when an item is sourced from a remote site, for example, the available to promise or capable to promise calculations will return a projected date based on that remote site's own ATP, CTP calculations plus the transit time. So the net effect would be materials end up where they need to be across your entire organization. So the last technical section we're going to cover here is 2 things that I'd like you to consider to determine whether or not your plan is trustworthy, how you will handle capacity and bottlenecks, and the engineering data that will sit underneath it all that will make sure that your planning and scheduling maintains a high level of accuracy. So first question is, and I'm sure most of you, if you're using APS, have considered this before, is whether to use finite or infinite capacity. So that's a discussion that I know lots of companies that I'm working with are having that discussion currently. There's a strong desire to be able to capacity plan, because in the real world, your resources and your resource groups, they do have a limited amount of work that they can complete in a workday, and most companies are not necessarily constrained by the market. They're often constrained by machines or people on the shop floor that can only complete so much work at a time. So I just want to be precise. So APS can schedule with finite capacity planning or with infinite capacity. One thing to note is for most customers, Infor's official recommendation is to use infinite APS. And the reason for that, and any of you that worked with me on this topic before, the main reason for that is most companies actually have flexible capacity. So you may have a set number of people, or you may have a set number of machines that run through a critical business process. But a lot of companies I work with, when we discuss what we should model as bottlenecks in the system, they're actually able to throw more resources at a specific task when they need to. So maybe you've got, 4 assembly workers on a production line, for example, but you can pull in additional people if you've got high volume going through that production line. You can pull them off of other production lines, pull them off of material handling or something like that. The reason why Infor recommends most companies use infinite APS is because if you look at true manufacturing processes, many organizations out there do have flexible capacity. And that's really what the purpose of APS Infinite is for. APS Infinite is, technically speaking, it does not consider capacity constraints when planning and scheduling, but which at a functional level means that any specific resource or resource group is able to exceed 100% utilization. What that means is you handle your capacity outside of the automatic scheduling. So you add more people to a specific problem, throw more people at a job order, run a job order through multiple machines instead of one as needed, and you essentially, get it done on time, doing what you need to do to be able to ship out the door. That would be an infinite APS environment. Finite APS, conversely, is where you have inflexible capacity. So maybe you've got, as a really simple example, you've got one machine that is a critical business area that a lot of your routings will run through, and it can run 8 hours a day, 5 days a week, 40 hours of uptime, and you don't have an additional machine, you don't have an alternate production process, you're not able to outsource production when you need to. Everything or mostly everything has to go through this specific resource. And if this resource is down, that means that you're going to have delayed shipping out the door. Or if you have higher volume that goes through that resource, that means that you're going to have an overall reduction in throughput in your manufacturing system. So that's a scenario where we would want to model finite. So finite scheduling is a better option when capacity is genuinely inflexible. You've got a single stable chronic bottleneck, utilization at that bottleneck that is regularly above 80%. Any of you that have worked with me on finite APS before, you'll hear me talk about that 80% threshold as defining a bottleneck. That didn't come from me or ESS or even from Infor. That's an industry standard terminology. If you take any supply chain, production planning, certification, or course, you'll hear the same thing when they talk about bottlenecks. It's regular utilization above 80%. So the best practices to keep your data accurate from an automatic planning and scheduling perspective is to limit the number of constrained resources in your system. Sometimes you'll hear Infor mention 30% as a target to fall within that number. So that means no more than 30% of your shop floor setup is finite. Technically speaking, if you want to look at the official recommendation in supply chain and in Infor's documentation, it's based on the 80-20 rule. So the 20% of resources that cause 80% of your delays, essentially. Yeah. So if you do decide to set up your system as finite, if you're currently working on that, limiting the number of your constrained resources to what has the greatest impact, regular utilization above 80%. Reviewing those bottlenecks and running capacity planning on those bottlenecks daily. The simpler that you can keep your model from a capacity planning perspective, the more trustworthy it will be. So I've seen companies before schedule their entire shop floor as finite. That's maybe that's legitimate. They've got bottlenecks all over the place. But the more complexity you model into your system, including building out bottlenecks that are finite constrained, the more difficult it is to maintain the scheduling accuracy, because small variances in permutations in runtimes and operational availability, bills of materials, etc., routing steps, small differences and variations between what's modeled in the system and what's actually happening on the shop floor, they compound together in the higher number of resources that you model as finite. So we want to keep the model as simple as possible to make sure that we are setting the pace of production, that drum buffer rope principle in TOC, to what are truly the constraining resources only. And as an effect, your other resources that either feed those bottlenecks or are fed by those bottlenecks, their pace of production will be set to that bottleneck level, same as anybody that's read the goal, theory of constraints, methodology, anything like that. All right. So what we've discussed here today, none of this works without accurate engineering. That means your bill of manufacture, your BOM, and your routing is the foundation for reliable automated scheduling. APS will calculate release dates based on your current operation times and based on the constraints of the bill of material and the routing and the resources that are assigned to that routing. If any of that data is wrong, your projected dates will be wrong. So it's a classic situation of garbage in, garbage out. The discipline that's required is to keep your routings accurate, your runtimes accurate, the resources required for those routings accurate, keep your bill of materials up to date, your inventory levels accurate, and make sure that you are recording shop floor transactions in a timely and accurate manner. And that ties into Factory Track if any of you are using it, Shop Track, or some of you are potentially on some of your own shop floor job transaction records. But at the end of the day, timely and accurate data inputs will allow the schedule to have more accurate data to use when it's planning the next day, the next week, the next month of production. That's the price of admission for trusting the plan, is maintaining that level of discipline. To tie it all together, here's the inputs and outputs for APS for that 3-pass planning and scheduling engine. On the input side, we've got the demand, which could be customer orders, job orders, forecasts, master production schedules, safety stocks, projects, etc. We've got our supplies as an input, so that's on-hand inventory, incoming purchase orders, incoming job orders, transfer orders, project receipts, resources. Sorry, resources is the next row. For the resource input, we've got the resources on the shop floor, the resource groups, your scheduling shifts, when your business actually runs, when your different resources are scheduled to work. Are they on one shift or two or more? Modeling holidays in the system, so non-working days, weekends, things like that. Your bill of materials and your routings, as we talked about, are critical inputs to the APS method, as well as your item parameters and your planning parameters. The outputs of APS are projected dates for customer orders and job orders, service orders if you're using service, projects for projected dates will apply as well. Your order suggestions from APS, so those are what we call PLNs. Those could be planned job orders, planned purchase orders, planned transfer orders in a multi-site or multi-plant environment. Your resource allocations are outputs, so the soft allocation of your resources, how they're utilized, what that load profile looks like, the production schedule. Your material allocations, including the supply pegging and shortage identification, and then your exception messages, the warnings from APS where you are in trouble of not being able to adhere to the plan for whatever reason. So if we look at the inputs, we need accuracy in all these areas. Good data in, the outputs will then be trustworthy. So a couple things to take away just before we get to the questions section here. So as we discussed, APS exists to make and keep an accurate promise date via that 3-pass planning method. The multi-location, multi-shop floor, multi-site choices come down to whether or not you need legal entities and financial reporting, multi-site when you need separate financials, multi-shop floor when you just need independent planning. The multi-warehouse coordination will keep your cross-site promises honest with transfer demand and transit time. The recommendation to keep capacity models simple, as we talked about, infinite for most, finite only when you've got true bottlenecks on the shop floor. And all of the above rests on accurate engineering, maintaining an accurate bill of manufacture, bill of materials, and routing data. All right. That's the walkthrough of the topic that we plan to cover today. So I'd like to open up the floor to questions. If you have any questions about applying this in your environment, what that release schedule looks like, or anything else that's related to what we talked about today.
We have one question so far, Brendan. Um, what's the timeline for multi-shop floor planning implementation? Is that something we can set up and use today?
Yeah. So as I mentioned, if you are on MRP, multi-shop floor is available to you today, albeit you do need to request a beta key, which we can definitely assist you with the process on how to do that. There are companies out there that are using multi-shop floor for MRP now. For APS, because it's a different planning engine, that's still in development from Infor. Last I spoke to them about it, which was at the Sun conference this year. They had in the roadmap the plan for that to be a beta release for October, the October release in 2026. Keep in mind, for any of you that are on-prem, that would require an uplift to the October 2026 release to be able to use that beta key. So then subsequently to that, if I remember correctly, I believe that Infor has indicated that the MRP multi-shop floor will be in full release later this year around, I believe it's around October as well. The APS release, I don't think they have a date defined for that yet. It probably depends on the adoption for the beta key and who actually starts testing that out and providing feedback to Infor.
Thank you. I don't see any more questions, but I think we can wait a couple more minutes for more questions.
Yeah. Yeah. If anybody has any questions about what we discussed or anything about planning and scheduling in general, I'd be happy to answer them.
We got one more question. I think I missed this point. Let's say someone sit there with 5 plants. Do they need full multi-site or just multi-shop floor?
Yeah. I mean, really, for me, the decision point would be whether or not you've got a requirement for separate financial reporting or separate currencies. If you do, multi-site, which has been around for quite some time, multi-site would be a better fit as multi-shop floor doesn't provide any functionality around uh, splitting up financial reporting or different currencies or separate legal entities, whereas multi-site does. So there's probably some of you out there that are using multi-site currently for what really would be a better fit for a multi-plant environment. Um, Previously, multi-site was the only option if you wanted to plan a different facility independently. Otherwise, you kind of had to make it work, treating it as one facility within a site. But now we've got this new functionality that's coming out as per popular demand. So there's been a lot of requests to get this, and there's quite a few organizations out there that I've talked to personally that they manufacture more than one facility, but they really are just one company, one currency. So yeah, if you got 5 plants and all those plants are same currency, same legal entity, then multi-shop floor would be a great fit for you.
We have one more question. If different brands are entering sales orders, how would order entry change between multi-site versus multi-shop floor?
Yeah, so multi-site, the sales orders would be created individually in each site, so there'd be separation there. There would be individual customer master files. The sales orders would have their own order numbers. They would exist with their own site reference. In a multi-shop floor environment, you would enter in sales orders the same way you would in a single site environment, but you would specify on the order what warehouse you're sourcing the inventory from. So similar to any of you that are using separate warehouses for distribution centers, it'd be similar logic from an order entry perspective. The main difference would be once the demand comes in, that would trigger that planning logic for that specific plant.
Okay, thank you. And we have one more question. How about multi-sites with different currency?
How about multi-site with different currency? Yeah, I mean that's a common use case for multi-site is being able to define separate currencies for each site. So in that scenario, if you had separate currencies for different manufacturing plants, you would definitely want a multi-site setup, especially because being in different currencies and different countries, you would have a separate legal entity regardless. So that would be a fit for multi-site.
We have one more question. Could you use multi-shop floor to help you plan if you have a lot of subcontractors with many jobs at any given point going through? You wouldn't have the on-hand control, but to provide guidance and you own the material, they would not have access to your system.
Um, that, yeah, that's a good question. So it sounds like what you're asking is, could you use a multi-shop floor to basically help plan for your subcontractors? Uh, I would say if you are a single facility and your manufacturing occurs at a single facility, I would probably model that using the outside processing functionality rather than multi-site. If there's a consignment inventory component to it, we could also look at vendor consignment implementation, which doesn't require multi-shop floor. One of the big benefits of multi-shop floor, in my opinion, well, there's a couple really, but being able to model your own resources and resource groups by warehouse is a really big one that you don't get out of the box with a single site planning and scheduling environment, and also being able to properly model material requirements for those job orders that exist in each warehouse. There's currently not really a great way to handle it, and anybody, if there's anybody in the call here, you probably know who you are. I've worked with some of you on this, but if you've got multiple manufacturing warehouses in a single site without multi-plant, you'll find that you have difficulties in proper material allocation and pegging between sites currently. So those are some of the issues that that's meant to resolve.
And the last question, there's an addition as well to put a constraint or capacity on the subcontract operation. So if I don't know if you can see it, the last question from
Um,
the chat section.
yeah, I may have to stop sharing my screen to be able to pull this up. Let me just take a quick look here. Is it in the chat or the Q&A section?
In the chat. In the chat.
Okay. Okay. Yeah, I see it here. So could you use multi-shop floor to help you plan if you have a lot of subcontractors, as well as, okay, the second part, as well as to put a constraint or capacity on the subcontract operation? Yeah, I mean, I don't know that you would require multi-shop floor for that. You could technically, I haven't tested this personally, but you could technically set an outside processing resource and a resource group to finitely scheduled. I haven't tested that. Trish, I know we're having some ongoing discussions about planning and scheduling. Let's talk about that in more detail after the presentation.